recording now. Yeah, so by now we have discussed about the main data type, that is list. Okay, so list is we discussed as it is ordered sequence of the items. So indexing is allowed. It can contain multiple data type. It is mutable. So once created, you can change anything. So we saw how we can append a new element. We saw how we can use the extend and to add the multiple values at a time. Then also we saw how we can remove multiple elements from the list. Okay. Apart from this, there are few more functions are there um,
Mhm.
in list. So some few functions in list. So one of those function is um, sorting. So sorting of the list elements. So there are two functions. One is sort and another one is sorted. So let's suppose we have a list. I'll just take my list is equal to, and I'll take multiple elements like 56, comma 89, comma 32, comma 45, comma 78, comma 40, 54, and 90. Okay, like this we have element. Right now, uh, what we are going to do is we have to sort the list. Okay, so sorted my list is equal to, and then here we have to give sorted and my list. Okay, now when I'll print my list and I am printing sorted my list. So you can see here and the difference between both. So this is the list that originally I created, and this is the list that has arranged the list into the ascending order. Okay,
Okay.
okay. And if you want to arrange the same list into descending order, so sorted um, my list um, 1 is equal to sorted my list, comma, reverse, not reverse, descending is equal to, not descending, there is some other keyword. Uh, yeah, reverse is equal to true. Reverse is equal to true. True. Okay, so when I'll do this and when I'm printing this, sorted underscore my list, sorted underscore my list one. So now you can see here it has arranged this into descending order. Okay, so by default, by default, it arranges into ascending order. Okay, and then when reverse is equal to true, then arranges in descending order. Okay,
Okay. So
okay,
can you
so
explain the line sorted my list is equal to sorted my list, and then here you have given reverse is equal to true, right?
oh, sorry.
Can you please
Um, I,
explain
I,
that line?
I didn't get your question. Can you please repeat?
Can you please explain the line sorted my list is equal to sorted my list? And then again here the reverse is equal to true. I
Yes.
understand the concept. Can you please explain writing this? Uh, what you
So
have used as
basically,
a
Basically, this sorted function is to arrange the elements either
Hmm?
in ascending or descending order. Okay.
I got
So
it. Yeah.
when I supply this my list into this sorted function, so what it is doing is it is by default arranging this my list into ascending order and storing that list into this variable, and that's what I am printing over here.
Okay, got it. So
Okay.
here reverse is equal to true.
Yes, here the additional thing I have done is reverse is equal to true. So now it has arranged the same list into descending order now.
Mm-hmm.
Okay, clear?
Sorted minus is equal to sorted minus. Why you have given reverse is equal to true? You can give simply reverse, right? No?
No, no, reverse. This is the syntax. Only reverse, if you are giving, it will not work. It will give an error because reverse is not something that works automatically. It needs either in positive or negative directions. So see, it is giving error because reverse is not any keyword over here.
Okay. Oh, it's not a keyword.
Okay.
Reverse is not a keyword. Okay.
No, reverse is not a keyword. See, you can see all the keywords over here are in green. You can see you see any keyword,
Yes.
any
Mm-hmm.
this keywords are always available in green only in this environment.
Okay.
Okay, so you can see here this is not green, this is black.
Mm-hmm. Got
Okay,
it. Got
so
it. Okay.
so that's how it is working. And
Okay.
so you have to give reverse is equal to true, and if you give reverse by default, reverse is equal to false is there. So that's how it is arranging in ascending order. But if you want this to be in reverse, then you can write it like this. Okay.
Okay. Okay.
Okay. Next thing, so this is the sorted function. So what this sorted function doing is it is sorting all these elements and storing the sorted list into a new variable. It is not arranging in the same. But what if I want to arrange this list itself in sorted order? Okay, I don't want this to be stored in another variable. I want this list itself to be sorted. So for that you have to use my list dot sort. Okay, like this when you will manage and when you will print my list, so it will sort the list itself. Okay,
Okay.
and here also if you want to arrange this in descending order, then you have to write over here reverse is equal to true. Okay, and then it will arrange in descending order. Okay,
Okay.
so if I write my list dot sort and reverse is equal to true I am writing, then now if I am printing my list, it has sorted the same list in descending order.
Okay.
Is it clear?
Clear. Yeah, clear.
Okay, great. So like this you can do the sorting of your list. Then if you want to do like reversing of the reversing of the elements. Okay, so suppose this is my list I'm taking again is equal to 67, 45, 32, 45, not no, 45, 89, then 21, then 97. Like this, I have taken element. I want just the entire list into the reverse order. So what I'll do is my list dot reverse. Okay, so first of all, I'll print my list over here, and after this, I am printing my list over here again. Okay, the same list I'm printing twice. So you can see here, this is the one which I originally created, and this is the one which is reversed now. Okay, in just reverse order, not ascending or descending. It is just reversing the entire list.
Oh, you just called my list the reverse. we have really created. How it is reversing here without true.
No, it is the internal process. It is the means as of now, it is doing all these jobs automatically. In C, C++, you might have studied the entire algorithm to reverse anything or to sort anything. But here, for now, you just need to understand for data science, you don't need to think that how it is sorting or how it is reversing. Okay,
Okay.
although you can study those all those things as well, but that is not a part of data science. That is part of that is when I teach DSA, data structure and algorithm. In that I tell how to reverse using code, how to sort using code. Okay.
I got it. Here you have printed my list dot reverse, right?
Yes, yes.
So I'm asking. So you already showed how to sort.
Your
You
voice
so
is
sorry.
breaking up in between.
So firstly, you showed me to sort and then reverse, right? For reverse, you
Yes.
said reverse is equal to true. We have to give. So here you have given only reverse. That's what I'm asking.
So this is reverse function, and this is the reverse attitude attribute. Okay, this reverses function.
Okay.
Okay, and this reverses attribute of this sort function.
Okay.
Okay, so both are different. So you
Okay.
both are different, both are being used at different places, and that's how they are acting different. So this is just sorting in reverse order, and this is just doing the reverse order.
Okay. Mm-hmm. All right.
Okay.
Got it.
Okay, so these all the small differences are there, and thanks for asking. It will make your work clear, your concepts clear.
Okay.
Okay, so now next, what we are going to do is uh, some com- comprehensions in list. So there are few things are there in list. Like if I have a list, suppose my list is equal to, and I'm doing 4 comma 5 6 7 8 9, and here I am what I'm doing is just print my list into two. Okay. So here, what it has done is this is entire list. Okay. Now when I have done my list into two, so what it is doing is it is just printing the entire list twice. Okay. It is printing all the elements twice.
Okay.
Okay. And suppose if I'm doing print of my list plus my list. Okay. So, and I'm executing this. So again, it is doing the same thing because it cannot because list is not a integer data type. This is a list data type. So that's why it is just in concatenating both the list um, in all together. Okay, so this is the small thing that you need to understand. Now we are moving to next data type. Okay, so next data type. So this is again now. Let's say it is H4, and this is user defined data type, and this is tuple. Okay, we are going to take tuple. Okay, this is H4, and here I am taking first one, tuple. So so tuple is again it is ordered data type. So in this, indexing is allowed as it was there in list. Okay, it can have multiple data types together. Okay, then third thing, and how why it is different from the list, how it is different. So it is immutable. So immutable means once it is created, nothing can be changed. कुछ भी once you have created, आप इसमें कुछ भी change नहीं कर सकते. Okay, and the fourth thing is it is denoted by parenthesis. Okay, so these all are the properties of tuple. So all the things are same as list apart from it is immutable means once created and nothing can be changed, and then tuple is denoted by parenthesis. List was denoted by this square brackets. Okay, so let's create a tuple. So I am creating tuple as tuple 1 is equal to, and now I am giving elements, suppose 56, 34, 21, 89, and um, ABC, then comma PQR. PQR I am taking. Then apart from that, I am taking false, and then I'm taking 67.98, and then I'm taking true. Okay, so there are multiple data types you can see, and if you want to print this tuple one, and if you want to print the type of tuple tuple one. Okay, so I'll just execute this. So you can see here this tuple is created, and its type is tuple. Okay, now, uh, if you want to access any element, so the same indexing can be used. So indexing is same as list. So this starts with 0. Okay. So if you want to access any element, so you can access it like print tuple 1 of suppose 0. Let's see, then I'm printing another element, print tuple 1 of suppose 5 I am printing, and then I am printing some other values. So print tuple, and I am printing it from starting till sixth element. Okay, and then I am printing tuple, and then I am printing it from fourth index till last. Okay, and then printing tuple one, and I'm printing uh, third to eighth. Okay, like this, I am printing multiple types of values over here. So you can see here with this everything on it is working same as what we discussed in list. Okay, so this is printing just first element. This is at fifth index. It is from first end of zero index to 5 minus 1 index. Okay, and here it is starting from 4. This is starting from 4 and going till last, and
Okay.
here it is starting from 3 and going till 8 minus 1.
Got it.
Yes. Are you
So
asking
what
something?
is, yes. So what is then difference? I mean, from
I'm
the
I'm
few
I'm
percent
coming to
index.
that. I'm
Yeah.
coming to that.
Okay.
This is the difference part. I'm just coming to that. Okay, so
Right.
one difference is it is denoted by this parenthesis. You can notice over here. So it is parenthesis. Okay.
Yeah.
Then
Got it.
second difference is that if you want, suppose I want to add any add any element. So what I'm doing is tuple one dot append. If I want to add a new element, new val, so you will see that it is not allowing because in tuple appending is not supported. if I want to change anything at any particular place, so tuple 1 at suppose at fourth index, I want to add suppose XYZ. Okay, so again it will give you error because it does not support the item assignment. If I am trying to remove some element from suppose fifth index, so it is again not supporting. Okay, these all things are supported in a list, but here in tuple, anything is not supported. Only once it is created, you cannot change anything inside the tuple. Okay,
Okay.
you can access all these elements in the same manner as list is, but you cannot change any element inside the tuple.
Okay.
Okay, is it clear?
Yeah.
Okay. So the only thing you can do is you can just delete the tuple. So if you want, you can just delete tuple tuple one. Okay. The only operation you can do with tuple is, so let me print tuple first, tuple one here, and then I am printing tuple no, one after this. Okay. So I am printing print tuple one. Okay. So now you can see here I have printed when tuple one over here. It has printed the entire tuple, but when it is removed, you cannot it is not able to find this tuple one. Okay.
Yeah.
So this is the only operation you can do with tuple. Okay. Now sometimes interviews ask the question that what if we uh, define list inside the tuple or tuple inside the list. Okay. So this is both are supporting the multiple data type. So list can store list inside it and tuple can store tuple inside it. List can store tuple inside it and tuple can store list inside it. Anything is possible. So for example, let me create an list. So I'm creating my list is equal to, and I am creating suppose 56 43, and inside this I am creating a tuple. Okay, so I am doing 676, 89, 32, and 12 I have created, and then some new, some other well I have created. Okay, so now I have created a tuple inside list. Okay, so let's check my print my list and then print type of my list, and then again I am printing type of my list, and tuple will be at second position. Okay, so I am printing this. So you can see here this is the entire list is there. This is a list type, and inside this at second index there is a tuple. Okay, so when tuple is there, so the question comes is that list is a mutable data type. But if tuple is coming inside the list, will I be able to change anything inside the tuple? So let's check. If I am doing, this is my list of two, and under this I am taking, I am changing at zero, and I am defining this as 45. Okay. So you can see here this is at the second index. In this second index, this is the index is again starting from zero. This is one. So at zero, we have 76 is there. I am trying to change this into 45. Okay. So let's try to change this. So you can see here it is giving me that tuple object does not support the item assignment because this is a tuple. No matter where it is, no matter whether it is inside the inside the list or set or dictionary, anywhere it is, since it is a tuple, you cannot change anything inside this.
Okay.
Okay. Okay,
Got it.
the only thing you can change is you can replace entire tuple with a new value. That's it. So it will remove the entire tuple and it will place a new value at that place. Okay.
Okay. Mhm.
In the same way, I am giving the list inside the tuple. Okay, so this is a list inside the tuple. Okay, so my tuple is equal to, and here I am giving a tuple 4567, and then I am giving list. So this is suppose 11223344. Okay, I have given this and then other vowels. Okay, like this I have given. So this is tuple now. Print. I am giving my tuple, and then I am printing type of my tuple, and then type of my tuple at 2. Okay, so you let me execute this. Okay, one more closing bracket. Okay, yeah. So now you can see this is the entire tuple. Type is tuple, and inside this at second index we have a list. Okay. Now, if I want to change anything inside the list, so my list, my tuple at 2, and here I am trying to change any element at one index, and I am doing this is new well. Okay, and now if I print this, so my tuple, so you can see it has added a new value over here. Okay, if you want to append element or you want to extend any element, my tuple of 2 comma 1 uh, to, 2 dot extend and I am giving suppose 335566, and I am doing this print my tuple. So you can see here it has extended the new elements over here. So the overall thought with this is that no matter which data type is at which place, either you are using tuple inside the list or you are using list inside the tuple, it will retain those properties at that particular place. Okay.
Okay.
So no matter where list is, it will be able to apply all its functionality no matter where it is. If list is there inside the tuple, any element of the list can be changed. All the new elements can be added inside the list. Okay,
Okay.
understood?
Yes.
Now so just I'm giving hash uh, remove the tuple. So to remove the tuple, you have to use del function. Okay, so del function, with del function, you will be just able to remove the tuple. Okay, yeah, we have discussed this. Yes, we have discussed. Sorry, I forgot that I didn't. I was thinking I have not discussed. Any doubt with this so far?
No.
Okay, great. So next is what? Next is set. Okay, so let me write it in Markdown. So this is H4 user defined data type, that is set. Okay, so set is basically it is a um, so like tuple and list were the order sequence. It is not an order sequence. It is unordered sequence. Okay, and that's the reason indexing is not supported. Okay,
Mhm.
then the second thing comes is that mul- multiple data types are supported. Okay, then the important thing is that duplicates are not allowed. Okay, if duplicates provided, it removes the duplicate values. Okay, and it is basically denoted by curly braces. Okay, any doubt so far in this?
No. No.
So let me demonstrate it. So this data type is set. So how to define the set? I'm taking my set. This is definition of the set. Definition of the set. So definition of the set is yes, my set is equal to, and I am just giving it like this here. This is suppose I am taking 23, 45, 67, 89. Then again I have given 56. Then I am giving 45, 23, 11, 7, 87. And again I am giving 56 over here. So now you can see I have given multiple duplicate values over here. Again I'm giving 45, then 76 I am giving. Okay, now, if I print this my set, okay, so you can see here I how many elements I have given. I have given more than 10 elements. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 elements I have given, but here how many elements are there? Only 8 elements are there. Okay, now now, why only 8 elements? Because duplicates are not
Not all
supported.
of.
So,
No.
if you provide the duplicates, it will remove those duplicates. Okay.
Okay.
Another thing to be noticed over here is that I gave the 67 over here, but 67 is coming at the starting. I gave 89 just after 67, but here it is coming at this place. Okay, it has not arranged anything, right? 76 was at last, 76 is here. Okay, so any element you give, it will not be at same place. So by this you can observe that this is unordered sequence, and since it is unordered, so if you try to write my set of suppose three, if you try to write the indexing over here, and if you try to set print my set of 3. So you can see here it is telling you that this object is not subscriptable. Not subscriptable का मतलब है कि you cannot use indexing with sets. Okay,
Okay. Mhm.
okay. Any doubt in this?
No.
Is it easy?
Yes. Yes.
Okay, okay, great. So now if you want to add any element in the list, in the set, right? So to add any element into the set, simply you have to use add function. So my set dot add, and you cannot give any position over here because set is not supporting the index. So just you have to give the element, it will add. Suppose I am giving 90, and now if I want to print my set, you can see 90 is not there right now. I am printing, so you can see here 90 is added. Now it is coming at last does not mean that it is at last position. It can come at any position. If suppose I am printing over here my set again, it is showing at the same places. So basically, there is no fixed place that where it will come because it is not supporting the indexing. Okay. Then
Yeah.
if you want to add a list over here, multiple elements, okay, so you what you can do is my set dot add, and you can give them, suppose if you are giving the multiple elements from here itself, so it will not support. So 22, 50, 55 and 77 I am adding. Okay, so it will give you error because the add function only supports one argument at a time. Okay, only one argument at a time. Okay, so what if you want to add the multiple elements, right?
Mm-hmm.
So when I want to add multiple elements, I can give them through a list 22, 55, 77. Okay, when I am giving like this, okay, and when I am printing now, print my set, you can see okay, it is not supporting. Okay, okay, yeah, this is not very much supported in case of set as well. Okay, so let's see, removing how we can do removing of the elements. Yes, in set you can add just one item only at a time. You cannot and let's suppose it has support of the multiple data,
It won't
so you
support a
can.
list, right? Set supports list, no or no?
Sorry,
Set won't
sorry.
support list, right? No.
No, no, no. Set
No.
won't support the list. Yeah,
Yeah.
uh, in set you can add. Suppose I am taking set one is equal to, and I am giving values like this, 45, 78, and I am giving like A, B, C. I am giving, and then I am giving Python over here, and then I am giving 78.90, 78.90, and you can see it is supporting the multiple data types. Okay, there is no issue with that. It is supporting the multiple data type. All these are in list, and you can see Python has come at very beginning, while I have given Python over here. Okay, so like this, um, you can give the multiple data types as well inside the set. Okay,
Okay.
any doubt with this?
No.
Okay, now um, the yeah. So now removing the values, removing elements, removing elements from the set. So to remove element from the set, simply we are using the remove function. First one is remove function. So remove function is, now suppose I have this my set. So I'm just removing the value from my from this. So my set dot remove, and I'm removing 89. Okay. When I print my set, you can see it has removed element, right? So
For removing also we can do one by one or we can do it.
no, you have to do one by one only. It
Okay.
because it search the element, and if it exists, it removes. Okay, but if
We
it
do
is
a
not there,
complete set. Can we do
if, if,
complete set?
if it is not there,
Mm-hmm.
it will generate an error. Okay, so now here I have already removed this 89. Again I'm trying to remove this 89 over here. I'll just see, it is telling me that 89 is not existing. Means the element that I have given over here is not existing. It is giving me an error. Okay. Okay, so in this one more function comes, that is discard function. Discard function. So what this function does is it also searches the element, and if it exists, it
Can you
removes.
please spread? Okay. What is the element?
Okay, so remove and discard both are doing the same task but behaving the differently. How they are behaving differently? So suppose now if I want to remove my set dot discard, and I am again trying to remove 89. So it will search for 89, and if exists it will remove. But if it don't find the 89, it will not generate any error. Like here it is generating an error. Okay, but
Mm,
here in case of discard, if it does not exist, it will not create the noise. It will just be quiet, right?
okay.
It is quiet. Okay,
So,
if it did not find, it will not give any error. Okay,
mm.
so this
So if
function,
it
if
finds 89, will it give the message like
no,
that
if it finds it,
discarded?
if it finds, it will simply remove. Suppose I'm putting 87 is there. Okay,
Mm,
so if it finds, it will simply remove. In both case, it will not generate any output, whether
mm,
it exists or not.
mhm,
Okay.
mhm.
So now after this, you can see print my set. You will find that there is no 87 now. Here it was 87 was there. Here 87 was there. But now there is no 87, but it has not created any noise, right? So how it is different from the remove? It does not generate the error if element don't exist.
What is the
Okay,
use?
sorry.
What is the use of this? This that
The
function. I
use
don't.
the use of this is that if suppose you have made a system where you are trying to remove a certain value, right? And with that automation, if you are using the remove function, so if the element does not exist, it will stop the process and generate the error. But in case of discard, it will not stop the process. It will keep on continuing the process.
All right. Mhm.
Understood?
Yeah, yeah, got it.
Okay. Then the third one is the pop function for removing. So it removes a random value from the set. Okay, it will just remove a random value, my set dot pop, and I'll just print my set. So here you can see all these elements are there. Now see what element is remaining. So what it has removed? It has removed 67. Okay, okay. Again, if I'll execute the same, you can see here it has removed the 11. Okay, so it will just remove any random number from the set. Okay,
Mhm.
understood? Any doubt? And then the most favorite function, that is del. So del function removes the entire set. Okay, so if I do del my set and I'll print my set, it will say that it does not exist. It is not defined.
Yeah,
Okay, so del is common for all, for set also, for tuple also, and for list also. Del is common everywhere.
okay.
Clear?
Yeah.
Now, next, in further, now with set you can do some operations. So, um, operations with the set. What operations are there? So you might have studied the set theory. Have you studied the set theory in let's say 10th or 11th?
Yeah.
Did you study?
Yes, it's a group of. Yeah, yeah. Yes.
So what all concepts were there? Can you just name few? Can you name anything?
So, is it, oh, we studied the join and set.
Huh?
Joins we have studied and set, I believe.
Okay, no issue. I
Um,
was just asking. No issues.
okay. I don't
So
remember. Sorry.
I'll just tell. Don't worry.
Mm.
So do you remember the union,
Yes, yes, union intersection. Yeah.
intersection,
Yes, union
then
intersection. Mm.
difference, symmetric difference? Now, can you tell something about union? What is union?
Union
Don't
means
worry.
it will
Don't worry.
if for the two sets we will take the common one.
So, common part is in intersection only. Common values. Common values. Okay. Let me just remind you. Let me open this paint. You will. It is very easy. I'm just trying to tell you what actually it is. Is my screen visible?
Not that.
Can you see it?
Yes.
Okay. Okay, so when there are two sets are there like this, okay, at one place these are like this, then second place also they are like this, okay. So when we are taking just this place, right? So this is
Yes.
what is
Intersection.
this is
Mm.
intersection, and union is all of this, everything.
Yes. Yes.
every Everything we are taking, and the common values are considered just once only, okay, because common value are there in this also. This is a, and this is b, so common values are there in both. So common values are taking just once only, okay. Then differences, suppose I have given this a and a minus b. Okay, so A minus B is this, just this portion, right? And B minus A is just right one. Okay, understood?
Yes.
So this is the difference. And symmetric difference is all values except the common values. Okay.
Okay.
Now let me tell you. Okay. So in the intersection is on only common values, all values including the common values cons- considered once. Okay. Difference is um, all values of one set except the common values. Okay. And symmetric differences all values of both sets except the common values. Okay. Got this?
Yeah.
Okay, so we are going to do the operations according to this. So suppose I am taking set A, okay, and here I am taking um suppose 1, 2, 3, 4, 5, 6, okay, and then set B I am taking, and here I am giving 4, 5, 6, 7, 8, 9. Okay. Like this I have taken. Now, um, so when I am going to find the intersection, intersection is equal to, I am giving set A and and set B. Okay, when I'm printing this intersection, so you can see here it is showing just the common
Oh,
values. Okay, just the common values of both sets. Okay, clear?
yeah.
Okay, then now I am giving the union. So set A and set A or set B. So print union. So it is giving me all the values, including the common values considered at once. So all the values from both sets, common values are considered just once. Okay, then I am doing difference A. Difference A. Okay, so I am doing set A minus set B. So it will print all the values from set A except the common values. Okay, so sorry, diff A, difference A. Okay, so it is just printing all the values except the common values. Okay,
Mhm.
all the values.
Except the common values in set A.
Sorry,
No, no, no. Yeah, go ahead.
from set A except the common values with set B. The same vice versa you can see in the set B minus
B
set A.
minus set
So,
A. Mm-hmm.
so it will print 7, 8, 9. Okay,
All right. Mm-hmm.
clear?
Yeah,
Give me a second, I'm getting a call.
all right. Okay.
Okay, sorry. So now last one is symmetric difference. So symmetric difference, symmetric difference is equal to set A, and we have to use this operator over here. Okay, this operator, and then I'll print set B. So if now I am printing symmetric difference, so you can see here it is it is printing all the values, and not 4, 5, 6, because 4, 5, 6 are common in both.
Mhm.
Okay, clear?
Okay, clear.
And apart from these, so let me write the illustration. All the values from both sets except the common values. कॉमन वैल्यूज. ठीक है, इतना समझ में
Okay.
आ गया?
Let's see.
कोई डाउट तो नहीं है?
I don't understand Hindi question. Sorry. So I don't. I don't have any doubt. Yeah.
Okay, so here we are doing this through these operators. You
Mhm.
can do this with the functions also. So for example, I'll just do in one part int ints intersect is equal to, and I am doing a set a dot intersection of set b. If I am doing, and I am printing this enter int sect. Okay, I am printing. So like,
No, in
sorry,
the wrong. No, no, print, print.
yes. So with this function also you can perform the same kind of operations, right? So I'll just write all the functions for you. So you union v, I'm just taking set a dot union, and I am doing set b. So if you, in case if you don't remember the symbols, you can do in this way as well. Union v. Okay, and then diff diff set b, okay, is equal to, I'm doing it with set b dot difference and set a. I am printing diff underscore set b. Okay, and then symmetric differ I'm using, and set a dot symmetric symmetric underscore difference. Symmetric difference I am taking, and okay, symmetric difference, and I am taking set b. And when I am printing this over here, print symmetric differ, and I'm just printing. So now you can see here it is also uh, differ. Okay, symmetric difference is there. DIFFERENCE. Okay. Okay. So you can see we are getting the same output over here. Okay. Is there any doubt?
No,
Easy है?
yes, yes, I think so.
Okay. So if means you can use these functions also if in case you don't remember these symbols. Okay. So now next one more thing in the set part is this is called um, frozen set. Frozen set. So frozen set is basically you can do all the operations, but once it is created, nothing can be
Okay.
changed. Okay.
Mm,
So basically, once it is created, it is frozen.
got it.
Okay. So to apply a frozen set, you have to use, suppose now I have fr set I am taking, and here I am giving, I have to give like frozen set, frozen set. Okay, this is the keyword. Everything is small. Give me a second. My laptop is getting discharged. I have to connect my charger.
Okay.
Okay, so this is frozen set. So in frozen set, suppose I am
Just a
taking
minute,
this.
just a minute.
Am I audible?
Yes.
Okay, so this is frozen set. I am supplying some values over here. So I'm giving 5, 8, 3, 2, like this. I am taking, and Just printing fr set. So you can see here, um, this new set is created, in means, and these all values are frozen. Now, if I am trying to add something fr underscore set and trying to add a new value over here, suppose I'm trying to add 56, so it will give me error, that because frozen set has no attribute as add. So once it is created, you cannot change anything, you cannot add anything, or you cannot remove anything.
Okay.
Similar to tuple.
Okay.
Okay,
Okay.
clear?
Yes. Yes.
Any doubt?
No. No. You hear me?
Mm,
So
yes.
no questions as of now and no doubts.
Okay. So frozen set supports all these operations, these intersection, union, symmetric difference. All operations are supported. So just let me write all operations like intersection, union, difference are supported. Okay, so you can try these things by yourself, and
Mm-hmm.
it will work in same manner.
Okay.
Okay, so like this, you can these all are, this is all about sets, and the last data types comes in this is this is called dictionary. Dictionary. Okay, so dictionary is basically this is another data type, and it is consists in key and value pair. Okay, key and value pairs are there. Keys cannot be duplicated. Then keys can be used as index for this, and it is denoted by again this. Okay. Um, Let me write the break also. Uh, okay. Is it clear to everyone? Ah, sorry.
Yes. Yes.
Okay. So now how you will define the dictionary? So suppose I am taking my dictionary is equal to, and I am taking this curly braces, and I am giving one colon, and then first bell. Okay. Anything you can give. Then second, I am giving 2.002.00009. Okay. Then three, I am giving, and I am giving, suppose, okay. Then four, and four, I'm giving like fourth, fourth value. Okay, like this, anything you can give. And now, if I'm printing my dictionary, okay, so you can see here it is coming like this. Okay,
Okay.
okay.
Mm-hmm.
Um, yes. So now, if you want to access any of element, so now default indexing will not work. So if you try to do use my dictionary, and default indexing start from 0, it will give you that this is not, there is no key like 0. Okay. So let me write default indexing not will not work. Okay. But if you try to write my dictionary of one, you can see it is printing. This is first value. Okay. If I am trying to write it as two, it is giving me this value. Okay.
I saw
So
it's not for 0 and for 1 and 2. Uh, so it takes from 1.
no, it is not taking from one. Since I have given it as one, so it is taking that. Okay, you can give any value over here. So suppose I am taking my dict one is equal to, and I am giving it like suppose I am starting it at 101, or I am giving any character value like suppose I am giving this as first, or I'm giving just A. Okay, just A, and here I am giving 1, 2, 3, and this B I am giving at 4, 5, 6. Here I am giving C, and I am giving 7, 8, 9. Okay,
Yes.
so now if I try to use this my dict one, so you can see this is like this. Okay, and if I am taking now my dict one and A I am doing so. Sorry, here I have to give it like this, and here you can see here it is giving me this value. Okay, so whatever value you are giving over here, this is the key and this is the value. So whatever the key name you will give, it will act in same manner. It's not necessary that it will start from one or zero. Okay, if you instead of one you will give zero, so it will print that also. Okay,
Okay.
since I have not given zero, so it is not given zero over here
Okay.
because it is not finding this zero.
All right.
Okay,
Okay.
so like this you can do anything. Now, suppose if you want to add a new value, so add new value to dictionary. Okay, so for that simply you have to introduce a new key. Okay, so my dict one, and I am introducing E. I am introducing E, and I am giving value as 1122. Sorry, 1122. I'm giving, and when I'll print now, this is my dict one. Okay, so you can see here this. Okay, so dictionary is also an unordered collection. So it is not ordered. This is also an unordered collection. Okay, so default indexing is not supported. Okay, the indexing that comes from default will is not supported. The index that you have defined through your definitions will be supported. Okay, is it clear for you?
Yes.
Okay, now if you want to change any element, then you can change the, suppose you want to change value at C. Simply what you can do is my dict one, and I'm giving it C, and here I'm giving, suppose instead of 789, I'm giving 7788. Um, okay, let me write it like this. Okay. So print my dict one. So you can see here this value has come. Now, the important part is that the index cannot be duplicate. Why? These values can be duplicate. These values can get duplicated, but index cannot be duplicated. So, for example, if I am giving my dict one, I am taking a new dictionary. I am giving a. I am giving x is equal to x, and I am giving 1. Okay, and then I am giving y. I am giving 2, and I am taking z. and I'm taking 3 3 at this place. So here I have to give like this, and I'm giving 3 3. This equal to will not support over here. Now again I am taking x, and I'm taking this suppose 4 4. Okay, and again I'm taking y, and this I'm taking as 5 5. Okay, so you can see here I have given y over here also, and y over here also. The same way x is there. That's why both I have given duplicate. So now if I print my dict 1 1, so you can see here it has taken this second value, this second part, and it has discarded this first part. The first values that I have given has been discarded by the dictionary, while the second value I have given are being considered. So whatever the latest value is there, that will be stored inside the key. Okay,
Okay.
okay,
Yes.
okay. And if suppose I am giving my dict 1 1 of z. So I'm changing this z value again to 55, suppose, is equal to 55. So you can see here, print my dict 1 1. So you can see here now y and z both have 55. Okay. So overall saying essence is there. Index cannot be duplicated while the values are allowed to be duplicated. Okay.
Okay.
Clear it? So we have learned how to add a new value. We have learned how to duplicate the value, how to change the value. Now, if you want to remove any value, okay, so my dict 1 1 1 and I'm trying to remove a value. Okay, so my dict dot remove, and I'm trying to remove this 55. Okay, if I print my dict 1, this is 1 1. Okay, this is 1 1, and here now you can see here uh, this dictionary has no such object of remove any element. Okay, so dictionary does not removes any element based on the value directly. Rather, it removes the element based on the index numbers again. So my dict 1 1 dot pop and I am trying to remove the index z. Okay, and when I'll print this my dict 1 1, so you can see here it has removed this index. Okay, so removal of element is possible via index. Okay, so
Okay.
in dictionary, basically, indexes are given more importance than the value. Values can be anything, but index can be limited. Index cannot be duplicated. Okay,
Okay.
understood? Any doubt?
No. Yeah. I got. I got it. Okay.
So this is all about the user defined data types. If you have any doubt in understanding, you can just go through whatever we have discussed so far. I'll share this file right after the session, and you can go through with that. And if you have any doubt, you come up with any kind of questions, you can come back and you can ask me those questions. Okay.
Okay. And please don't forget to share the recordings.
Sorry.
Don't forget to share the recordings too.
Yes, yes, definitely. I'll share the recording once it is generated. So it takes some time. Immediately after